Hey everyone, and welcome back to
Another one.
Welcome to Program Code 101, the place where we learn the art and skills required to develop code. I'm your instructor, Mr. Decoder. In our previous video, we looked at the concepts of array manipulation, including how to search for and sort items stored within the array. We also generated pseudocode using one-dimensional arrays that searched for and manipulated items stored within the array. If you missed the details of that video, please select the link above to review. In today's video, we will be looking at the concept of flowchart development. We will also be generating flowcharts using various pseudocode constructs, including sequence, selection, and repetitive constructs. What is a flowchart? A flowchart is a graphical representation of an algorithm. It uses shapes that represents the processes of the algorithm and shows the steps as well as the order of execution. Flowcharts, like pseudocode, can be used to analyze, design, document, or manage a process or program. Flowchart symbols. The symbols used within the flowchart are the most important in the process of developing a flowchart. If the symbols used are incorrect, this affects the integrity and correctness of the algorithm being described. The basic and most commonly used flowchart symbols include terminator symbol. This is represented by an oval and is used to indicate the start and stop point of the flowchart. Process symbol is represented by a rectangle and is used for processing statements, such as calculations and/or assignments. Input or output symbol. This symbol is represented by the parallelogram and is used to indicate data being entered by the user, as well as information being displayed by the algorithm. Decision symbol. This is represented by a diamond. It is used to represent an evaluation, question, or condition within the algorithm, and is used to indicate that a selection and/or repetition statement is being used. Flow symbol is represented by a line that can be directed to point downwards, to the left or right, and occasionally upwards. The flow line indicates the direction in which control, or data, moves within the flowcharts. Connector symbol is represented by a small circle and is used to indicate the connection between options within an evaluated condition. It can also be used to connect different points of a flowchart if there is a breakage in flow from one page to another. Flowchart construction. The following guidelines are essential when constructing a flowchart. 1. Flowcharts should start at the top of a page and flow downwards to the bottom. If there is need for more than one page, connectors are used to show corresponding points of the flowchart. 2. Flowchart instructions should be written inside the symbol being represented. 3. Symbols should be drawn large enough to enter instructions, so they can be easily viewed. 4. Processes within the flowchart should only have one entry and one exit point. 5. Decisions or evaluations within the flowchart should only have one entry point, with two exit points. The exit points can be labeled true or yes, and false or no. Example: constructing flowchart using sequence construct. The following example indicates that a pseudocode should accept three numbers, add the numbers together, and output the result of the addition. The solution shows a short pseudocode illustration which outlines the sequence of steps required. Mirroring the sequence of the pseudocode, the flowchart uses ovals to show the start and terminating points of the solution. Separate input/output symbols are used for the prompt and input statements shown. The process symbol is then used for the calculation of the sum of the three numbers. The result is then shown using a parallelogram for the output. Example: flowchart using selection construct. The pseudocode shows the prompt and input of a student's mark. The algorithm then evaluates the mark entered to determine if it's greater than or equal to 60. If the condition is true, the word pass is displayed, otherwise the word fail is shown, after which it terminates. The start of the flowchart is represented with the oval. Then, it uses two parallelograms for the prompt and input of the student mark. The decision symbol is then used to show the evaluation of mark greater than or equal to 60. Note: the keyword if doesn't have to be written inside the symbol. The result of this evaluation can be true or false. The words yes and no are respectively used for this. Note: it does not matter whether yes or no are on opposite sides of the diamond. The most important thing is that the correct flow of control is shown based on evaluation. This means the word fail needs to be shown if the condition is false, and the word pass shown if the condition is true. Once the respective output has been displayed, the flowchart will terminate with the keyword stop, shown in the oval. Example: flowchart using repetitive construct. This example illustrates the use of pseudocode that initializes a variable, sum, to 0. It then prompts for and allows the input of a number. A while loop is then used that first evaluates whether the number is not equal to 0. If this is true, the number is totaled. The process of totaling using loops was completed in a previous video. Feel free to review the contents of that video for further clarity once you have completed this one. The result of the totaling process is displayed once the loop terminates. The flowchart representation begins by using the oval to indicate its start. The process symbol is used for the initialization of the variable, sum, and is then followed by the prompt and input of a number using the input-output symbols. The decision symbol is then used for the evaluation. Is number not equal to 0? If yes, the process symbol shows the total being generated, followed by new prompt and input symbols to accept a new value. This new value is then re-evaluated to determine whether the loop continues or is terminated. If the evaluation for the while loop is false, the loop will terminate, and the option representing no will be selected. The sum of all values totaled will then be displayed using the output symbol. The flowchart solution then terminates through the use of the oval containing the keyword stop. Flowchart. Question: the following problem requires the design of a flowchart from the given pseudocode. The pseudocode accepts a group of numbers and finds the largest number among the values entered. The pseudocode continues the acceptance and evaluation of numbers until the value 999 is entered. Once the value 999 is entered, it then displays the largest value using a suitable label. Analyze the given pseudocode, then generate the most appropriate flowchart based on the outline provided. Pause the video now and construct the flowchart. I will show you the solution in a moment. The solution shows the oval being used for the start and stop points of the flowchart. It then shows the process symbol, which is used to initialize the variable, largest. Input-output symbols are then used to prompt for and accept a number, after which the decision symbol is then used to determine if the value entered is not equal to 999. If yes, a second evaluation is done immediately to determine if the number is greater than the value stored as largest. If that is true, largest will be updated with the value stored in the variable, num. If the condition is false, the sequence continues by accepting a new value through another pair of output and input symbols. Note: the branches of the if statement are concluded with a circle, used as the connector between both points. The new number accepted will then be re-evaluated to determine whether the loop continues or is terminated. Once the value 999 is entered, the flowchart shows the use of the output symbol to display the largest value. The solution then ends through the use of an oval, indicating the terminating point of the flowchart. In the next video, we will discuss the concepts of using advanced flowcharts to represent data systems. We will also construct advanced flowcharts from given scenarios, including system requirements. Thank you for being a part of
another one.
Remember to like, comment, and subscribe. Until next time, take care.